one about the vision. I have read. Let's show the video first and then discuss. Okay?
Okay. Yep.
Half transform.
Yep.
Present a robust approach for crop row detection in harsh conditions. We use an agricultural robot body row operating system.
Yep.
Our approach supports different sensor sources. In this case, we use laser range data to segment vegetation. We use a novel algorithm, the pattern half transform, to reliably estimate the correct crop row pattern. The classical half transform extracts the best matching line from 2D input data. These could be used to build a crop row pattern. In contrast, the pattern half transform searches for a crop row pattern directly. That is, it finds the best match of parallel equidistant lines. This enables us to robustly find crop row patterns even under harsh conditions like these sugar beet plants. In their emerging phase, plants are hard to see for the human eye. We use a high-resolution RGB camera and apply vegetation effects, the triangular greenness effect, to highlight plant features. These are projected onto the ground plane as a feature map that the pattern half transform works on. With our approach, crop row detection is possible even on small target crops that aid the new precision farming applications.
That's very good.
Yes. Bunny rope. Something like this.
Yep. Are
How
you?
do you see something like this?
Well, generally, there's like this image processing pipeline where you would give it different transforms. Like the first that they used is that RGB or camera filter. Generally, there's like a series of operations that you do. I've never done it with row crops. I've only done it with on-road vehicles. So detecting row lines.
Your connection is not good, stable.
It's cutting in and out. I've never used that transform on plants, only on on-road vision systems to detect street lines.
The voice is not clear.
Okay. Yeah. So did you find the paper on how they put that together?
Yes. I will share put the link on the chat.
So are you familiar with computer vision processing?
Not at this level. But there is a course in Udacity. Do you know it? From Georgia Tech. Here is the link.
I was looking up a pipeline, an image pipeline for you. What was the question?
How to start building this vision system? I know
Okay.
this is not a specific question.
Yeah, well, it can be big. There are some that are available. Finding lanes, it's like an intro to computer vision, but it kind of explains how you how you process an image for creating lines. I'll show you.
They are using the half transform.
Yes. Yeah, uncanny edge detector. So there's a couple different algorithms that you use. I'll show you. Show you one.
All these topics are introduced in a university course, Introduction to Computer Vision.
Yes, yeah, it's great. Very, very useful.
I am in the beginning until now.
Okay, can you see this screen?
Yes.
So this is from Udacity, and basically you're taking in video feeds from a camera. You're masking the area that you want to look for, the lines, or it could be beat rows, and then you are using the Hove transform and canny edge detector to transform this image and then be able to find these lines, and then you paint these lines back onto the ground. So this is a similar pipeline that you could use, except for in the beginning of the video, they talked about the RGB camera. And so you may need a little bit of maybe a filter or something else on the original image coming in. But what's nice about Udacity is it's open source and they have their projects out on GitHub.
This is the link of the course, if anyone maybe use it.
So I can send you a link about how they solve these processes. So we also do some other effects on the images, but you'll have to find out what works best. But here's a link to an article that talks about each of the transforms. So we switch it to grayscale. You do some different things to make those lines stand out. You would need to do the same thing with the beats, and then you put it through a couple different algorithms to find where those beats are and where that line is, how they're connected.
Yes. The hardware needed for this process. The cameras, the type of cameras, RGB or the high vision, I have told you before.
Yep. I'm not sure exactly which camera would work best for seeing the plants. Maybe it's listed in that paper from Bosch.
RGB, they are using RGB.
Yep. So there's an example of a pipeline, of an image pipeline processing to find lines out of an image and then paint those lines back on a video stream. So you're taking a video stream, slicing out each of the individual images, applying grayscale or some color modifications so that what you're looking for stands out, and then you do the transforms, and then the canny edge detection will tell you where the line is.
Yes. They need the PC or computational power needed for this. How large is it?
That's a good question. I've only done it on a laptop, just a regular laptop. I'm not sure if it'll run on like a Raspberry Pi or what's the minimum computation power you'll need.
Do you know anyone have worked on a project like this before?
We can post in the Slack channel and see if there's anyone.
No one is answering. Until Jeff. Only Jeff is answering me.
Hardware questions. We need to ramp up your software development team there in Egypt.
We are only 4, and we are seeking only 2. All the team will be 6.
No computer vision people there?
There is a lot of computer science students, but in the project we can't merge with them the project.
Okay. Can't merge with them yet.
What?
Have you asked them for some help, or they see if they
Yes,
want to?
we are working, but in unofficial way, friendly way, only friendly way. I have searched for a simple robot to start. It is a line follower, just like the IR line follower, but using computer vision to detect the line and using ROS.
Yep. There are a number of examples out there on GitHub that have different image pipeline examples.
Yes.
I don't know if there's one specific for plants. There's the I thought there was one paper specifically on sugar beets. Like here's a paper. And there are some image data sets out there for sugar beets.
The Bunny Rob have published some data sets I have showed before. But the main problem is that the size of the planet starts small and then be larger. This is a critical problem. Yes?
A critical problem because the beet changes shape over time.
Yes. As you show in the video, it starts very small.
Yeah.
So the GPS here will be helpful in the beginning. Yes?
The GPS may be helpful.
Yes. Okay. The point with the motors, but I think it will not be suitable.
Have you decided on what motors for your robot?
Yes, I have now two options, only two options. Either using a brushless DC motor, hub DC motor. This
Yep.
motor comes with the wheel, not the tire, only the wheel, and I will assemble the tire on it.
Excellent.
Okay. The other type tends to be an industrial solution. Is to use an induction AC motor with a driver. But the AC motor is of type called gear motor. This type comes with a built-in gearbox.
Do those hub motors, do they come with encoders built in?
I will post a link. Just the power challenge is a big challenge. Here is the link of the motors. This is a hub motor, brushless hub motor. Come with the wheel, and the tire is assembled over it. Have you seen it?
I just pulled it up now. It's pretty neat.
Yes. Some colleague working on an electric car prototype told me about it.
That's excellent. What do these motors cost?
Nearly $400.
Okay. So you would
power
use
is good.
the what?
Their power is suitable. 3 kilowatt.
So you think you'll use 2 of these on front?
4.
Okay, you have 4 powered, and then the articulated middle section.
Yes.
Cut your
But
turn
the
radius
control
down.
of this articulated. What?
That'll, if you have that articulated in the middle, that'll make your turn radius smaller.
This point is still under discussion, not defined totally until now.
Okay.
But I have found a design on GrabCAD for a simple mechanical sprayer that uses the same mechanism, the same articulated steel.
Do you have a link to that?
Yes.
So do you think that, oh, it comes in different wattages. You can get that all the way up to 8 kilowatts.
8 kilowatt?
Yeah. That motor,
Yes.
that's amazing.
It has a controller. Just take the input from a rotary motion. As I told you, this type of motors is used in the electric vehicles, prototype electric vehicles. It takes the input from a rotary motion. We may use a servo motor to move it. I will try to open the SolidWorks. Have you worked before on SolidWorks?
On what was that?
Eh? What?
Have I worked on what?
SolidWorks.
SolidWorks. No. I've used Onshape before. Have you seen Onshape?
Yes. I have worked before on the design of the suspension mechanism of a Formula student car.
Did you have a link to that design?
Yes, but I am trying to open it on the computer and share with you.
How cold does it get in Cairo in the winter?
What again?
How cold? Do you have farming year round there?
Again, please.
I was wondering if how long your growing season is there.
How what?
How long your growing season? Do you get snow? Is it too cold in the winter time to grow?
Yes.
Oh, it is?
3 months.
Yeah. 3 months.
Yes. Here is the link. just the same design of the swarm farm.
I didn't see the link in the chat.
I have posted it. The last link, grab cat library set to provide prices bearer.
Oh, I see.
Yes?
Yep, it ran together. Yep.
Okay.
Ah, see, yeah, very cool. You made that.
Not me. I found it by Google.
Well, that's interesting.
Yes.
So those front wheels are solid and it only turns in the middle.
No, they are four-wheel drive, and in each wheel there exists a hydraulic motor in each wheel.
Yes, but the wheels don't turn. It's only
No.
forward reverse.
Yes, and the hinge in the middle is causing the steer. I have a video.
Okay.
Maybe clear it.
Pretty simple design.
Yes. But the point that make me confusing until now is the steering control of the pistons in the middle. This is a critical mechanism to control.
Did they actually make this machine or is it just a prototype design?
We are trying to manufacture it. Let's see the video. Here is the real one.
Today we're looking at our League Acura Spider Classic.
It's just dark. There's no video showing. There it is.
Until now?
Yep, now it works.
Yes.
Command that we've been getting for a more simple version of our high clearance tractor. This machine takes most of its technology from the machines that this company really built its history in the high clearance tractor business on as many as 25 years ago. So it has some newer technology in the hydraulics and a little newer technology in the engine, but a lot of the componentry and the basic design is still the same. And again, we've
Higher the quality.
reintroduced it due to the demand. So we're going to go over some of the features of it today and point out what has made this machine so popular and why we're getting the demand again that we are. As I mentioned, this is actually a classic Spider, so you'll notice that it's blue as opposed to the colors of our other machines. But this is a very basic machine that was historically built for spot spraying in row crops. So you have very easily adjustable row width, and you have very easily adjustable
As the swarm farm.
clearance due to the way
Yep.
it's used for row crop farming. So this machine easily adjusts from 60-inch row centers to about 96-inch row centers. Doesn't quite go to 100 inches on just this basic model, but goes well beyond 90. Then you'll also notice that this one is equipped with a spray gun that is coupled to a solution tank because, again, it's been primarily used for tires and wheels. They are traction rubber. It is four-wheel drive in the hydraulic system. So this machine is very capable of going through virtually any terrain. Maximum speed on this machine, as it says, is about 8 miles an hour. So anything that you need to do that requires high clearance, adjustable spacing, and a 5 to 6 mile operating speed through the field is what you need. And this machine should be able to cover it again on a very simple, basic platform. It does have an adjustable seat in the operator station with the seatbelt. Notice that it has side steering and a foot control on the hydrostat, which propels the machine forward or reverse just by actuating the pedal. Side steer so that the operator has good vision out in front of the machine and can actually operate the slot spray gun at the same time. Once you get beyond the basic machine, you can add other options as this machine has added to it. It does have a lift valve added to it, as you can see on the rear of the machine that this one has. So here on the rear of the Elite Classic Spider, again, this is a basic model that has had a couple of things added to it. You can see that here we have the rear lift that's been added to this machine. Parallel link arms on both sides provides a lot of adjustability. So these cross tubes can be moved anywhere in here. This main tube can also be moved up and down so we can keep that rear boom close to 12 inches from the ground, depending on what your machine height is set at. As well as you can go much higher than the machine should you be in an application that needs that. You're very adjustable on that. You can also see the hydraulic tank as well as the 20 horsepower gasoline engine that this
20 horsepower.
24 horsepower. That's pretty awesome.
And added as an option.
Hydraulic.
Yes.
It's actually a manual fold 30-foot thing. It's also equipped with a 3-section control.
With a 30-foot boom.
Control there in the
A very good design.
Yeah. Simple, easy to work on, easy to fix.
You will like things like this.
Yeah. Small engine on there, easy to adjust everything.
Yes.
Hydraulic, so you have a lot of power. Pretty big spray tank. I don't know how many liters that was. Was that like a 400 gallon?
450.
450. Okay. That's a nice design.
Do you want to see it in action?
Of course.
I will bring the video. Here is it.
Interesting.
What?
That's a really interesting design.
Yes. Very simple. Everything is available in this design.
Yep.
The main point, the only point that will make this design a little bit confusing is the control of the articulating steering.
It looks just like you're turning a steering wheel.
Not just simple like this.
Why?
As the controlling the hydraulics based on the sense the vision system will not be responding fast as motors.
Okay.
This point needs more study. I will, with my team, work on it.
So you think the being able to turn it is too slow? It's a little slow?
Yes,
Okay.
compared to the size of the machine.
Yeah, and you almost, you have to be driving to get that thing to turn.
What?
You have to be moving forward to turn it.
Yes.
That's a lot of pressure to stand in place and then try to turn the whole unit.
The jet posted a paper, and I was shocked that the project he posted has failed.
The project what?
The project he posted in the general Slack has
Jeff
failed.
has failed, the link.
Yes, I will give it to you.
I uploaded the paper that Jeff posted the link to into the Google Drive under papers.
Here is this.
Yeah, that one.
Unfortunately and extremely sadly, doesn't exist. I was shocked.
You don't want your robot to end up like this page, right?
Yes.
Unfortunately, it has ended. So what do you think your biggest risk is right now, or biggest challenge?
Cost, power, design, mechanical design,
Okay.
and ROS.
You have a few categories, but not too bad.
What do you see is the most challenge?
I like that design. I think that's pretty neat. I like how simple it is and easy to work on. I would be curious to find somebody in the ROS community that has worked on one of those, or how do you make a little prototype to make sure everything works okay?
We, as I told you, we are working on SolidWorks to design, build a CAD model.
Good, good. And for the power constraints, they're using hydraulic, which gives you a ton of power, maybe not a lot of speed, but if you go fully electrical.
Do you expect how much this hydraulic machine?
I don't know, 15, 20
Yes.
grand, I guess.
What?
15, 20,000.
More, little bit.
30,000?
Nearly.
More?
Nearly 30,000.
60?
30.
30,000.
Yes. Nearly.
That's pretty good.
We are building a robot for just 10,000.
10. Yeah. Well, the parts on that machine, if you want it, the parts, all of that machine the parts are probably around $10,000–$12,000.
Yes.
So if you want your cost to be, do you want your cost to be 10,000, or do you want to sell it for 10,000?
Cost will be 10,000.
Okay. Well, you're pretty close to that machine.
From which point?
So if something sells for $30,000 retail, then the parts, or the cost of the parts in that machine are around 10,000–12,000, maybe 15,000, but maybe right around $12,000. for the
You are
parts. So you're not that far off of building a machine like that.
ISA.
Yes, always, always. Would it be possible to get one of those machines used?
I don't think people use these machines in Egypt.
Okay. Yeah, I like the design. Fully electric is an interesting solution today if you have enough power. It seems like those hub motors have enough power to move through the field.
We are targeting the same power, 24 horsepower.
Targeting 24 volt.
Horsepower. The
What's
generator
20?
we-
What's
the
24?
horsepower.
Oh, 24 horsepower engine. Yeah, yeah.
Generator, not engine and the generator.
Yeah, so you can put an alternator on there to generate power.
Yes.
A small ATV. You can buy alternators of all sizes. So
A very huge challenge.
not too bad. I think you're closer.
You are motivating me a lot.
You got a good design. You've got the pieces. Things are starting to narrow down. As far as ROS, you can work on ROS for the next 20 years. So, but I mean, the software to 20 years easy. Yeah, sure. It never ends. It's just going to get bigger and bigger and bigger, more stuff. But to get it to go self-driving, that would be pretty quick. The vision system to detect weeds and other things, it just depends if you have somebody that you can get to help on the computer vision part. And mechanical, it looks like there's going to be a lot of mechanical work.
Our study in mechatronics is both mechanical and control and electronics, all subjects not concerned in a definite point. We can work mechanical, we can work electrical, we can work
Okay.
in many fields.
Okay, well, that's good. That's powerful.
To work in robotics, you should have knowledge in all fields.
Yes. Yeah, that's one thing that makes it fun
Yes, and complicated.
and complicated. Yeah, yes, very much so.
Yes.
So so this next week, your goal is to continue on the mechanical design?
Yes, and take a decision about articulated steering, if it will be good or no.
Okay.
And take a step in the vision, starting to define the main points, the hardware. If you can help me with the computational power I will need.
Yeah, I don't know how to answer that question. The computational power is a little bit of a trick. Most people, so it just depends on what you're trying to do with it. If you're just doing a simple machine learning pipeline like those, like that I posted in there in the chat room, those, I don't know if they could be run on a Raspberry Pi, but they're just not very computationally expensive. But a lot of people, if they're doing artificial intelligence or doing some heavy vision work, they use the Jetson, the TX1 or the TX2. That seems to be the go-to board for robotics now.
I have a headache about the heat and the suitability of this hardware in weather conditions.
Yeah, that's good. That's smart. It's hard. Yeah, heat.
I have a huge headache about this topic.
Yeah, heat is a major problem with electronics.
Yes.
Yeah.
Do you think how to take this point into consideration in the design process?
Yes, for sure. Yep. And it would be helpful to find somebody that has experience in making electronics for field use in your area.
All people tend to use PLC, not computers as we are using.
Yep. Yep. And those little like Allen Bradley, like industrial automation.
Yes.
Yep. Those are great. They're hardened. You can put those into a box. The one issue we have with robotics is you need a computer. You need processing power. So there are some companies that make a hardened computer that has cooling fans and everything on it.
Logic Supply is manufacturing computers in a small sizes with a heat sink and
Yeah.
a professional industrial design. It
Yeah,
costs
and you,
nearly about $500.
yep, for which size of processor?
If I can,
I mean, there are definitely more computers on the market now that are hardened, meant for being put inside of a vehicle.
yes. To solve this problem, advise me to solve this headache and do not be trapped in this
Without putting an air conditioner on your robot?
$10,000. $10,000.
Yeah, you're gonna need to put a cab in there with an air conditioner and filters for the air because it gets really dusty in the field. No, it's a
weather, but extreme weather conditions.
Yep.
They're under extreme weather conditions.
Yeah, so they do make industrial PCs that are rated for 80 degrees Celsius. So if you're really hot there, you definitely want to shield from the sun. Obviously, direct sunlight will kill it. And then having industrial components help.
Yes.
I've still gotten computers over 85 degrees C in the field, in hot areas. So still it's an issue, depending on how hot you are.
The names of the manufacturers of these computers?
They were proprietary computers.
Write please in the chat.
They were proprietary, so they are not available on the public market.
Yes. Okay.
But
Thank you
like,
very much for your reply.
no, hey, okay. Well, have you seen Rosie?
I am waiting with you until you finish.
Oh, well, well, there are a couple, like you're saying that Logic Supply has hardened computers. Those are good.
Yes.
The one with, there is a hardened TX2, it's called Rosie, but that costs $5,000, just the computer itself.
$5,000.
Yes, for a TX2 that's hardened, that's environmentally protected.
Against the sun, against the rain.
Do
against
what?
the rain.
Huh?
Against the water.
I don't hear.
Against the rain or water.
I don't understand.
Against the water. Water.
Water?
Water.
Like a water cooled. Yeah. Oil cooled, water cooled. Yes.
Okay.
How hot in the summertime is it there?
From 40 to 50 Celsius.
Okay. Yeah. Ask some of your professors about computers that they're running in the field. Try to find somebody that's got some computers running in the field. I can look around and send you some links for the hardened ones, but they can be expensive still today.
Okay, that's good.
That's good.
Okay.
So close now.
You see this?
See what?
That we are close.
Yeah, you're getting closer. So what's the goals you're going to have done by next Tuesday?
As I told you, the vision and
Okay.
the mechanical design. And I wish we will do as possible as we can.
Okay. Very cool. Anything else for today?
No, I have finished all the topics I can discuss with you.
All right. Well, I hope you have a good week. It's productive and you get some breakthroughs.
Thank you very much.
You bet. We'll see you.
Thank you. See you.